For thousands of years, our planet has enabled and nurtured our growing civilizations. Throughout the ages, our settlements have existed in balance with the natural world that surrounds us, protecting us from the elements, while enabling our societies to thrive. But now, in the space of just one human lifetime, all that has changed. The extent of our urban development has reached extreme levels, and our buildings now contribute more than 40% of all greenhouse gas emissions. Our actions are causing dramatic and irreversible changes to the planet that we call home. The critical links between ecosystems are being broken. But we have the power to turn this tide. We have the ability to limit the impact of the structures we build and to help them support rather than destroy our planet. The construction industry can make the difference, and with the help of new cutting-edge technology placed into the hands of billions, we can save our planet for future generations. Urban development is one of the main ways that human beings impact the Earth. From the structures that we call home, to our schools, hospitals, workplaces, and the infrastructure that we travel on, our built world now accounts for a significant portion of all greenhouse gas emissions produced worldwide. From initiatives to make entire cities carbon neutral, to innovations in concrete manufacture and even smog-eating buildings, the construction industry is beginning to recognise its role and respond. But much more needs to be done, and at a faster rate. To make a real difference, we must reach beyond the construction sector and enable each and every one of us to better understand how our buildings are impacting the planet. Technology can play a key role here, particularly in the form of the digital twin systems that have supported other sectors for many years. Creating a digital replica of a physical building that actually behaves like the real structure and provides crucial information on real-life performance can enable us to better understand how our buildings are performing and simulate how they may perform in the future under a range of scenarios. Leveraging artificial intelligence and machine learning, these so-called digital twins can improve energy resilience, reduce operating costs, increase resource efficiency, and help to decarbonise our buildings. When applied across a group of structures or even an entire community, we could start to analyse and improve our energy use at a societal level, reducing our impact on the planet. Digital twin technology for buildings is available and in use on real projects right now. Systems like the Intelligent Communities Lifecycle or ICL Environmental Digital Twin, developed by IES, combine building simulation and machine learning to provide insights on energy usage, waste heat, renewables, occupant comfort, and even transport connectivity. The ICL can replicate reality by simulating the physics of energy and heat flow throughout a building or a collection of buildings. Any gaps in real-world data can be filled with projections developed by the intelligent digital twin itself. Such systems allow energy and resource use in buildings to be clearly visualized, reaching beyond the barriers of complex engineering and engaging everyday people, from children to those who previously had little awareness of how our buildings can impact the planet and their lives.
The main reason to do this is because, of course, we want to improve buildings. Now, Lord Kelvin used to say, you cannot improve it if you cannot measure it. And so that's what the virtual build, the digital twin allows you to do. It gives you a prototype, a virtual prototype of the building that first of all allows you to measure it, but also allows you to test, to experiment on it without having to experiment on the real building. It's all about the data. So the digital twin in the end is a collection of data. For different use cases, it can look very realistic, like maybe the trend basin that we're looking at now, on my back, but also it can be just about data, about performance. So Because the data is available, means that we can use the data to share. And when we share, we make this information public. So we educate the public, and we hopefully create more engagement. That's what we need to solve the, let's say, climate change, to improve the climate.
With ambitions to become the greenest campus in the world by 2020, Nanyang Technological University have deployed IES's ICL technology across their 250-hectare flagship eco-campus in Singapore. Initially, IES created a master planning model of the entire campus site, accurate to 91% for total energy consumption. That model was then used as a baseline for high-level analysis on a number of energy reduction technology trials.
They had this vision. They wanted to improve the performance of their campus. They said, let's first create a very high-level master planning view on our campus and just tackle the low-hanging fruits. So are we using a set point that maybe is too low? So are we keeping the rooms at 17 degrees rather than more manageable 23, 24 degrees? Very simple intervention that already managed, after 1 year of, let's say, resetting all the parameters, they managed to save around 10%, 15% of the energy. This allowed them to analyze it, to test, to experiment the impact of changes, something that cannot really be easily replicated on site without using the digital twin.
In total, the use of ICL technology revealed a potential reduction in energy consumption of 30%, equating to potential savings of over 4.75 million Singapore dollars. IES's digital twin technology is currently in use on residential schemes as well. Trent Basin is a model low-energy community in Nottingham in the UK. Here, IES works with experts at the University of Nottingham to create an interactive platform that allows the community to visualise its energy data in real time.
Trent Basin is an area of the city of Nottingham on the banks of the River Trent, and it used to be an industrial area of the city and is now being redeveloped for low-energy housing. As near zero carbon as they could achieve. So there's lots of energy efficiency technologies and design elements that have gone into the housing.
Residents can interact with the platform online or at a large touchscreen in their community hub, moving around the virtual site, seeing the amount of energy being generated and their energy use.
What the architect was interested about was to create engagement with people that live in the community. So they know they've designed sustainable buildings, so they wanted to allow them to sit, in a way, almost to interact with the digital building.
The main thing was to visualize the data and to make the data more accessible and presented in a friendly way, to inform and engage the residents about the energy use and what has been produced, what has been consumed, and what has been stored in the development.
The platform means that residents can interact with and comprehend their energy use like never before, driving behavioural change.
You can really interact with a 3D model, you know. Sometimes for people that is not from architecture background, it's difficult to visualize 2D sketches or 2D drawings, and the 3D interactive platform actually helps a lot.
When you live somewhere where you're generating your own electricity, where you're living in a well-insulated home with lots of energy efficiency features, it starts to make you think more about your own living and your own environment.
It's also highly engaging for children, immersing them in the concepts of responsible energy management from a young age.
The platform was created to be inclusive and self-explanatory, so it allowing children and people with reduced mobility to use the platform and to interact with energy in the way that they never interacted before.
Residents can go and touch the various buildings and see not only what the building looks like, what are the main properties of the specific apartment, of the specific house, they can also go there and see what the current energy consumption is or what the temperature is.
We generate our energy locally using photovoltaic technology, solar panels. That electricity is generated locally and then it's stored locally in a large battery. At the time it was installed, it was Europe's largest community energy battery. Over the past year since this has been running, we've reduced an awful lot of carbon dioxide emissions associated with conventional generation.
The potential impact of this technology on a planet facing such an urgent climate emergency is considerable. Systems like the ICL can help us to better understand how our built world is performing and provide insight on how to improve it.
It's not just about having the technology running in the background, it's actually take the residents on the journey as well.
If we could integrate this technology into all the buildings within a community and then replicate that across multiple communities around the world, we could make a significant reduction in carbon output at a global level. The widespread adoption of such technology would also drive behavioural change, not just among the current population, but with future generations, enabling them to care for our planet long into the future.
Our biggest challenge as a country is how we decarbonise heat, how we get gas out of buildings and how we generate heat for a built environment. And one of the things that we're looking at here in the Trent Basin is how we can get maximum value out of on-site renewable energy generation, so electrical generation, how we store that locally and how we can interact and trade between the heat that we can generate and the electricity that we're generating here to optimise an entire system, to optimise the use of renewable energy for provision of both heat and power.
While the climate emergency currently facing our world is extreme, it is the construction sector that can make a key difference in turning the tide. With technology as our key ally in this fight, we can develop a more sustainable built environment, helping our planet to recover and thrive. If you enjoyed this video and would like to get more from the definitive video channel for construction, subscribe to the B1M.